Welcome students, this is Professor Pushkar Shinde explaining you the assignment 10 of microprocessor lab. It is related to finding out roots of quadratic equation. It uses 80387 instruction set. 80387 instructions are those instructions which start with F in the instruction. They are executed by the coprocessor when you execute on a program. It uses the same assembler NASM as you used for the assignments up till now that you have executed. So the execution steps remain the same in this program also. You will be using NASM to execute the program. The only difference will be that the instruction that you will be using will be used from the instruction set of 80387. So most of the instruction will be starting with F in the instruction. So looking at the program, as usual it is having section.data. Section.data is used to declare the variables that are being used in the program. So the formula that we are going to use to find out the roots will be your normal formula for quadratic equation, minus b plus or minus under root b square minus 4ac the whole upon 2a. For that purpose you have to initialize a, b and c values. So a has been initialized, b has been initialized, c has been initialized as per the example that we are solving for the quadratic equation. Then we are having the macro for write and read. Write is having the system call number 1 passed to RAX. RDI will have the handle to the screen. RSI will be the variable that you want to display, and RDX will contain the length of the variable, and we'll have syscall. So this is as usual as we display in the normal assembly language program. Similarly, there is a macro for read where RX has been passed with 0 system call number for reading, and we have the syscall. This is as usual as we are using in our normal assembly programs. Now as you can see in the program, the instructions are starting with F are associated with the 80387 coprocessor. So first instruction given is F init to initialize the coprocessor. FLD operand, what it does is that the operand is stored in the top of the stack. So what will happen is B will be stored in the top of the stack. So operand will be stored in the top of the stack using FLD instruction. Fmul, what it will do is that the operand will be multiplied with the value in the top of the stack. So top of the stack was having B, and operand is also being used as B. So B will be multiplied with itself. So you'll get B square in the top of the stack. Then FLD operand. Again, operand will be stored in the top of the stack. So A is the operand. So A will be stored in the top of the stack, and the other value in the stack is B square. Fmul operand. Operand will be multiplied with the top of the stack, and the stack top is currently A. So C will be multiplied with A. So you'll have A into C in the top of the stack along with B square below it. Fmul 4. So 4 value will be multiplied with the top of the stack value. So you'll have 4 into A into C in the top of the stack, and below that you'll have B square. The stack in 80387 has 8 values. There are 8 locations in the stack, 8 registers rather in the stack of 80387. So currently 2 are being used. So 4AC is in the top of the stack, and then you have B square. So F sub what it does is that the top of the stack 2 values are subtracted with each other. So what you will have is stack will be storing B square minus 4AC. So ST0 minus ST1, this is what happens when F sub is used. So B square minus 4AC will be stored in the top of the stack. Then FTST, this will compare the top of the stack with 0. So it will check whether B square minus 4AC is less than 0 or greater than 0. If it is less than 0, then there are no real solutions. It will jump to the label which is associated with no real solutions. But if b square minus 4ac is greater than 0, you will have square root of that. F sqrt finds out the square root of the top of the stack. So b square minus 4ac square root will be found out. FST, what it does is that it stores the top of the stack into the operand that is given with the instruction. So top of the stack, that is under root of b square minus 4ac, will be stored in the disc variable. So in this variable the top of the stack will be copied. Then f sub operand, what it does is that top of the stack is subtracted from with the operand. So operand is b, so disc minus b will be stored in the top of the stack using f sub operand instruction. F div, so f div, what it will do is that top of the stack will be divided by operand. So disc value will be divided minus b value, disc minus b value will be divided by 2 into a, because 2 times we are using f div instruction. So it will be divided by a and later on divided by 2. So in this way we have found out the minus b plus or minus under root b square minus 4ac the whole upon 2a value using the coprocessor instructions. Now another thing that is associated in this program is to display the value of the result. So for that, the same logic that we had used for displaying in our normal programs of assembly language will be used here. So what we will have is that the hex value will be converted to ASCII. Hex value will be converted to ASCII, and accordingly we will be having the values of result displayed in the program. So what we have is that if the digit is less than 9, 30 will be added into the digit. If the digit is greater than 9, then 37 will be added into the result, and that value will be displayed on the screen. So as usual, the way we were converting from hex to ASCII, the same logic has been used in this program. So if you have the digit value less than 9, then only 30 will be added to convert it to ASCII value, whereas if the digit value is greater than 9, 37 will be added into the hex value to get the ASCII value of the digit, and then that value will be displayed on the screen. So in this way the display logic is similar in the ways to the way that we were using in the assembly language. So this is a basic program to give you an idea of how coprocessor instructions are used in assembly language programming. I hope you get an idea about how you write programs using coprocessor instruction set. The macros are remaining the same, display and read macros are remaining the same. Even the logic of converting from hex to ASCII is remaining the same. Only the instructions like mul is replaced by fmul, div is replaced by fdiv. Similarly fld, fst, these are the instructions which are being used, which are associated with the coprocessor. So understand the concepts of the instructions of coprocessor and you will be finding it easier to write the programs for coprocessor. Thank you.